So if the third, fourth and fifth term in the expansion of x plus a power n are 84, 280 and 560 respectively, then find the value of a, x and n. Okay, so the third term will be like n choose 2. So n choose 2, and then you got like a power 2 and x power n minus 2. Okay, that's supposed to be equal to 84. Then you have the fourth term, which will be n choose 3 into x power n minus 3 and a cubed. That will be, well, what is this guy? Where was the question? Okay, 280. And you also have n choose 4 x power n minus 4 into a to the 4. That will be 560. Okay, so one thing which you see over there is that you got something like a ratio over there. Yeah, so if I multiply this and that, the power of x will be 2n minus 6, and then the power of a will be 6. So that is like 2 times the power of this term. So maybe I can use that fact somehow. Okay, so I think what I can do is that maybe I can multiply these two and then divide by the square of this term, and let's see what that value will be, right? So that will be like n choose 4 into n choose 2 upon n choose 3 squared. That will be something like this into that upon this thing squared. So are they like in some kind of, okay, no, there's nothing like that. Okay, this will be like 560 into 84 upon 280 squared. Just hope something cancels out perfectly and we get something nice. So that's going to be, let's see, so 560 into 84 upon 280 squared. 282s are 560, so we can use that factor. It's going to be like 2 into 84 upon 280. So that's going to be 168. Okay, how can we use that? Okay, let's just start reducing this. So this will be like 84 upon 140, which is, if I reduce by 4, I think that's going to be 21 upon, so you need 12, so 3, and then 20, so that's 35, which will be 3 upon 7, so sorry, 3 upon 5. Okay, so that's nice. This turns out to be 3 upon 5. Okay, so this value turns out to be 3 upon 5, if I have not made some mistake. And then let's see what this turns out to be. It's gonna be like n choose 4, which is n into n minus 1 into n minus 2 into n minus 3 upon 4 factorial into like n choose 2, which is just n into n minus 1 upon 2 factorial upon n choose 3 squared, which will be n into n minus 1 into n minus 2 upon 3 factorial into n minus 1 into n minus 2 upon 3 factorial once again. So let's see if some stuff cancels out. So this cancels, and you also see like this cancels. Okay, cool. So what do you get from that? First of all, this 3 factorial will cancel and you just get this guy over there, and this 2 factorial will cancel, just get 3 over there. So you will have 3 by 4, and then on the top you have like n minus 3, on the bottom you have n minus 2, I suppose. Okay, so that's right, this is supposed to be equal to 3.5. so yeah, we can actually find what this n is going to be. So like 5n minus 15 equals to 4n minus 8. So that's going to be like n is equal to 15 plus 8, which is 23. So that should kind of work. So n equals to 23, right? So let's just put that into this and see what we get. Okay, so n equals to 23 is one of the facts which we got, and we still do have to find the value of x and a, but I think now it will be much easier now that we have the value of n. So n equals to 23. Just why don't we erase this as well? Yeah, so like n choose 2 will be 23 into 22 upon 2, which will turn out to be like, you got 11 over there. All right, that's still not very nice, but fine, I'll just use that. So like x power n minus 2 and then a squared, that will be 84 upon n choose 2, which is 84 upon this stuff. So like it's not okay, so 23 is a prime, unfortunately. Yeah, whatever. 84 upon 23 into 11. Okay, and then you will also have x power. What I see is that like the ratio is somehow the same over there. So we can use that. But okay, whatever. We'll just see what happens. So like, yeah, let's use this equation instead. So x power n minus 4 and then e power 4 is equals to 560 upon this guy, like 23 choose 4. Let's see what that turns out to be. 23 into 22 into 21 into 20. Yeah, so what do we get? First of all, this is turning out to be 5. This will turn out to be 7. This will be 11. So 23 into 11 into 7 into 5. So this will be 23 into 11 into 7 into 5. Let's simplify. So it looks like it's a multiple of 7 into 5. So it's going to be, well, you got 80 over there, and 80 upon 5, that's just 18 upon 23 into 11. Looks nice basically. So yeah, I mean, we can square that, can't we? Right. So if I square that, I'm going to get like x power 2n minus 4 into a power 4 is equals to 84 squared upon 23 squared into 11 squared. But then this x power 2 n minus 4 a power 4 is the same thing as like x power n into x power n minus 4 a power 4, and we know what his value is. So we'll get 84 squared upon 23 squared, 11 squared. And yeah, we could also have like easily divided that thing to get rid of that x power n, but that wouldn't have got rid of x squared. So this is like the better way out. Okay, so we have eliminated a somehow. So we know this is going to be equal to x power n. Well, we know that n is actually just 23, so that's nice. It's going to be 23 over there. That's correct. And you got this weird thing, 18 upon 23 into 11. Right. Man, this is, wow, this is getting really bad. So at least we have found out what this x is going to be. If like x is positive, it should be positive because it's like an odd power, right? So you got 23 into 11 over there, and 84 squared upon 18, that's supposed to be equal to x power 23. So x is just the 23rd root of that. I'm out. I'm not going to do this at all now. So yeah, just put a correct over there because we tried and we did get the value of n somehow, and everything else is now just calculation. So you can put that value of x into this first equation to get the value of a. And yeah, I leave that to you. I won't do this further.